don't need it.
Yours isn't?
Do they not? You're all seeing the live when you use it. Wait, what? Yeah, see?
Somebody get one that wasn't double-sided?
I have two sides.
I think I
need
Okay.
Aaron,
Good.
just watch that one. Are they supposed to be
Where did she go? Oh, she had to leave.
No, it's supposed to be single-sided.
Okay, so today we're talking about the trapezoidal rule, and it's basically another way for us to approximate the area under the curve, and it's going to be used with functions that we can't easily find an elementary function that is the antiderivative. Okay, so I am recording it.
Where are you recording?
You guys want to say hi?
Hi, Chelsea.
Hi.
Wait, seriously, that's so sick. Oh,
She
wow.
can see you.
Did you hear us?
Yeah, she can hear you. Say hi.
What do you mean, like
Wait,
right
is
now?
it live?
We hope you get better. It is live.
Yeah. Are you
Oh,
serious?
there.
It's live?
Chelsea's sitting on her bed watching this right now.
Well, she'll watch it later.
That's gonna make her get sick.
Yeah. Sorry.
It's not really live.
Okay. It's recorded live.
Obviously, well, you have to record it live. That's cool.
rehearse it.
So,
She can hear us all talking.
what we're going to do
So she'll
here
be able to hear all awesome questions.
is instead of using rectangles to approximate the area like we did before, we're actually going to use trapezoids. Okay? So, if we're looking at these two intervals here, we can connect the heights, okay, of those two lines, and now you get a trapezoid. And you can see that that's going to more closely approximate the area than a rectangle would. Okay? It's getting pretty darn close there. And
because it has a taper in it?
because it has, yeah. We account a little bit for some bit of slope here.
So this will be similar, just kind of like instead of using squares, you now just follow so closely between 2 points.
Yeah.
The average slope.
I didn't get some.
Okay. So we're still going to go on an interval from A to B. So A is going to be x sub 0 here, and then we get x sub 1, x sub 2, x sub 3, and x sub 4, which is going to be our interval B.
Just as a question,
Mm-hmm.
wouldn't that, the distance between them be the h?
That's exactly right. So in this trapezoid function, or the formula here, it's 1/2 b1 plus b2 times h. And the b1 and the b2 are actually the heights of this function here. And then the h is the width of the function. So when we look at this,
Or does B stand for the base then, or no?
okay, so when we look at this, the h is right here, which is going to be b minus a over n. It's like your delta x. So that's how we found that before. And then the b sub 1, okay, is really going to be f of x sub 0. It's the height of the function at the points. And then here's f of x sub 1, which is like our b sub 2. Okay. So when we look at this, and we want to find the area of all of this, we would just take our first trapezoid, which is 1/2, times f of x sub 0 plus f of x sub 1. Okay. Times the height, which is b minus a over n. And that would be for the first trapezoid. And then we're just going to add it to the second trapezoid.
What's n?
That'd be how many segments you
N is the number of intervals we
So it'd
use.
be 4.
That would be 4 in this case. Okay. And then our second trapezoid would be
This seems like no one
f of x sub 1.
What's up with x sub 2?
Good. Times b minus a over n. And notice that doesn't change because we're going to take trapezoids of equal height. And the next one?
So then can we just put a delta x in for the b minus a over n?
Yeah, that would be fine.
Wait, we're doing this for all of them?
We're going to do all 4 trapezoids here.
Oh my gosh.
Um,
Why don't we just
um,
put the one half? And then in the very next second, we're gonna make it easier. I hope.
Oh man, and we have one more. So this is like a really long thing.
I'm gonna dot 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 it.
You could.
Can't see it.
Uh-oh.
So now they can show it.
We'll slide it over there. Okay, so some of you are probably picking up like there's got to be an easier way to do this, and it's dealing with summation a little bit. And so what we can do is we can factor out all the 1/2s, and we can factor out all the b minus a over n's. And so we actually end up with this formula right here, which is the trapezoidal rule. So it's the integral from a to b of f of x is approximately b minus a over 2n times. And you can see here now, we have an f of x sub 0. And then how many f of x sub 1s do we have? 2. And then how many f of x sub 2s? 2. So on and so forth until the very end. How many f of x sub 4s do we have? Only 1. And so we get this coefficient pattern of 1 times 2, 2, 2, 2, all the way, and then 1 at the end. Okay, kind of see that there?
Yeah.
Question?
So for what we're doing right now, we're gonna have a set n, like n's not gonna be.
Yes. You're going to have a set n.
Okay.
So in our example, it says use the trapezoidal rule to approximate the integral for n equals 4 and n equals 8. So we're going to do this in 2 different ways. So first, if we do n equals 4, okay, we need to find our delta x. So we're going from pi, or 0 to pi. So pi minus 0 over 4, which is just pi over 4. So we need to split the interval from 0 to pi into 4 equal portions. We want to find the x value at each one of these. So the first one will just be 0 plus pi over 4. The next one will be 2 pi over 4, which is pi over 2. And you don't have to simplify as you go. And the next one would be 3 pi over 4. And then the last one is just pi. So now you can kind of see our trapezoids here.
That looks like a triangle.
It is a triangle. So let's apply the rule now. So the integral is going to be approximately b minus a over 2n. So it's really pi over 8, because 2 times 4 is 8. Okay, now we just plug in the function with our coefficient pattern here. So it's going to be 1 sine of 0, because that's our first point here, plus 2 sine of pi over 4, plus 2 sine of pi over 2, plus 2 sine of 3 pi over 4, plus, oh, now we're at the end of our interval, so it's just sine pi. Question?
And it doesn't matter that the shapes on the outside are triangles and not trapezoid.
Nope, doesn't matter.
This is just based on the average?
Because it's based on the average. So this height, right, is going to be sine of 3 pi over 4. This height is going to be sine of pi, which we know is 0.
Wait, how do you get pi raised?
So it doesn't matter.
We used for n, we used 4.
I know, can you like write that?
Yeah, so You see right here this b minus a over 2n. So that's pi minus 0 over 2 times 4. Okay.
I thought you used like the same.
So the easiest way to do this is to find delta x and then double the denominator. Make sense? Find the delta x, pi over 4, and then double the denominator. Okay. So we're going to try this again, and we're going to separate it into 8 trapezoids here. N equals 8.
More precise.
So notice delta x is now going to equal pi over 8 and now we have twice as many trapezoids, which you guys are right, that is going to make this more accurate. If we let n go to infinity, then we should have a really good approximation. Now, for now, we're going to write the x's down below. You don't have to do this on your homework, because you know if we're going to go from 0 to pi over 8, then just keep adding a pi over 8. Okay, so this one might get a little bit long.
Sweet.
So what's going to be our factor out here?
Pi over 16.
Pi over 16, good. So we're going to double the 8. Then we just plug in all of our x values using the coefficient pattern. 1, 2, 2, 2, 2, 2.
Do the dot, dot, dot. And then finish off. Guess not.
So right now that whole big thing's our answer, or are we
Solve
gonna
it.
solve it?
You're gonna put this into your calculator and get a decimal approximation.
Okay.
That's what you're gonna do.
So this is taking the place of integral limit, essentially? Yes.
Mm-hmm. Okay. Now I'll trust you guys can type this into your calculator appropriately. Yeah. Is that okay? So when you get your approximation, go ahead and round it to 3 decimal points.
Oh.
Make sure you're in radians.
Well, I don't want to be in radians.
Got to be in radians too.
Wish I had known that from the
This is a pain.
Did you have to put
We need like a voice activation factor.
Should they actually already have one?
That is so cool. Oh, clear.
Okay.
Did they have a voice activation?
That's not good.
Maybe. So if we're looking at this right here, can you integrate this function?
Yes.
Yes. Okay. It would really equal what?
Cosine x.
From sine turns to negative cosine. So this would be, what do you get here?
No, I won't.
Wait, but no, am I gonna get a cosine?
Cosine 0 is 1. So negative 1 minus.
Wait,
Which is negative 1.
What's cosine of pi?
I didn't get 1.896.
Negative 1. Cosine of 0 is negative 1.
Cosine of 0 is 1.
Yeah, but it's negative. Oh, but
Negative
it's
cosine of
plus
0 is
plus.
1. Negative cosine of pi is negative.
Cosine 0 would be 1, and then negative would make it negative 1.
Wait, I didn't get 1.896.
So it'd be, and what's cosine of pi?
Yeah.
1?
Did I do it right? What did you get?
I'm not sure.
4.8.
What? What's cosine of pi?
Pi cosine pi.
Me
Cosine
too,
of pi is
right?
-1.
I got 1.97.
2.
What?
What did you end up with
Cosine is the x.
1.974.
for this one?
It's over here.
Or the bottom one?
Oh, I didn't get that one.
Bottom one, 1.974.
I'm doing it the other way. I'm just driving.
Wait, is this right? Can you look at my calculator?
Sure.
Diana?
Oh, you're missing the.
Times pi over 8.
Pi? What? What's he doing?
Oh, you did it.
Wait,
Negative.
Negative, positive.
That was.
I got it right.
Less, the answer's 2, and this is giving us 1.826.
No, it's 1.974 for the second one. The first one.
Yeah, it's getting closer and closer to 2.
It's 1.96.
As n goes to infinity.
Oh, it's 1.96.
Yeah. So we do get 2. 2 would be the exact answer, and you can see if we increase the thing, it's going to get closer and closer to 2.
So why don't
Okay.
you use the other one?
So why do we have to use the trapezoid rule? Is
And
because
integrate it?
look at this one. If we tried to use our u substitution,
It failed miserably.
1 minus x cubed, we could let that equal u, and then the derivative of u would be 3x squared. But do you see any 3x squared out here?
No.
No.
Could you times by 1 over 3x?
Oh.
Why not?
Nope. Because it's a multiple constant rule, not a multiple variable rule.
Yeah.
Okay? And so this is why we would have to use it for functions like this.
Wait, can you go back up to the cosine thing that you used?
This was just showing the exact answer. Because this is integrable. And we can...
So that's like an easier way to do it?
Yes.
But we're not supposed to do it that way?
Because if you get to a function like this, you can't use u substitution.
Basically, you just solve it, and you get to use whatever method you can to solve it.
Yeah, and this is the closest approximation we can. Because we're short on time, we're going to move on to the Simpsons rule.
Simpsons.
So we can make